Hey everyone, thanks for joining in today. I'm Vino. I work as a developer advocate at Snowflake, and today we are going to run sentiment analysis using Snowflake Cortex AI on Iceberg tables. So let's get started. First, with Iceberg tables, you are able to read the data that is external to Snowflake. Say, for example, you have some data sitting in your AWS S3, GCS, or Azure Blob, or in any external cloud storage. We are able to read and write that data from Snowflake using Iceberg tables. And to create an Iceberg table, we need to have an external volume and catalog integration defined. Why external volume? It's just a way of establishing connectivity between your Snowflake account and the cloud storage location where you have your data, just so Snowflake can read the metadata, like the Iceberg metadata and the actual data in the Parquet files, right? And once we have the external volume created, we could define the catalog integration as a way of making sure the data in your external cloud storage location and the Iceberg table remains in sync, in the sense it's automatically refreshed and kept in sync. Now, in this case, we are using AWS S3 for our cloud storage and Snowflake as a catalog integration. And once we have these two, we could create an Iceberg table. And for today's lab, this is primarily how the workflow looks like. First, we have to read the data and create an Iceberg table using the data from an AWS S3 bucket. And once we have this Iceberg table created, we also create a stream and a serverless task as a way to incrementally keep updating the dataset from your S3 to the Iceberg table. And then the third step is we would use the Snowflake Cortex LLM function, in this case, a sentiment analysis function, to actually run the sentiment analysis on the product review dataset. In the end, we will read the Snowflake managed Iceberg table from an external query engine like Spark. All right, to actually get started on the lab, let's go to quickstarts.snowflake.com and search for Iceberg Cortex. All right, I have the quickstarts.snowflake.com, and then let's go and search for Iceberg Quickstarts. So this is the one, sentiment analysis using Snowflake Cortex AI on Iceberg tables. All right, so for the overview, there's only one thing that I want us to focus on, which is one, if you don't have a Snowflake account, go ahead and create a free trial and then select standard edition while you do that. And then another thing, even if you do have an existing Snowflake account, it needs to be in one of these cloud regions to be able to run this lab successfully. So even if you have a Snowflake account, but it is not in one of these regions, please go ahead and create a free trial. We should be able to run the lab successfully that way. So I'm going ahead and creating a free trial. One thing, why do we need to have the Snowflake account in one of these regions? Because of the availability of Cortex in only these regions at the moment. So again, even when you create a free trial, make sure to select one of these regions. Now, we also are going to read data from an existing cloud storage in the form of Iceberg tables, right? So this cloud storage bucket also need to be in the similar regions, the one that you pick for your Snowflake account. So the Snowflake account and the cloud storage are both in the same cloud regions when you pick them, right? So I'm going to use AWS, the US West 2, like the Oregon one, for the entirety of this lab, which means I'll also use my AWS S3 from the same instance. So first thing, let's go ahead and create this free trial. All right, I'm gonna enter this data here personally. All right, so once you have your data entered, as you can see here, we could just keep it standard. We are not using any enterprise features today. Selecting AWS, US West, great, and then get started. And I already just created a free trial account, so I'm just gonna be using that instead. But you just get started, you would get an email, go to the email, click on activate your account. You will be able to just set a username and password for your Snowflake free trial account, and you should be good to go. And once you're done with it, you would also get another email saying log into your account. you should be able to log into Snowflake from there. As you can see, this is my free trial account. Let's get in. All right, so I have everything good to go. First things first, we have a free trial account with the standard edition in one of these regions. Fantastic. I will probably give us all a couple more seconds to log in and then, settle down into the Snowflake free trial account. Just giving us all a couple of seconds here. And once you have everything, if you're able to log into the Snowflake free trial account, let's move on to the next step, which is let's actually set up all the Snowflake objects that we need to run this lab. First is just creating a database and a warehouse, just the database and compute to run the lab, right? So I'm just going to copy these commands. Let's go to projects, worksheets. There's already a few of them. I'm just going to create a new SQL worksheet. Just going to run these. Don't need Copilot here. All good. So let's just go ahead and run these to create these demo database and the warehouse. All good. We were able to run that and create these successfully. The next step is let's go ahead and download this Snowflake notebook from the Jupyter one here. All right, this looks great. So let's just download this notebook. Fantastic. And upload that into our notebooks in here. Import from iPad the notebook, Snowflake. Fantastic. So now, what was the name of the database that we created? I think it was, I think demo was the name of the database. So that was good. The warehouse would be demo warehouse. Great again. So first, we created these database and warehouse. And second, uploaded this Jupyter notebook into our Snowflake account. So now let's just run through this notebook, step by step. As we saw in the presentation a bit earlier, before we actually go and create an Iceberg table, there is two steps prior to that. One, let's create an external volume. And two, we also need to create a catalog integration. First, getting started with external volumes, because I'm using AWS S3 here. What do I need to do here? I need to create an IAM policy, and I'm just skimming through the docs here. Okay, even before I create an IAM policy, I need to create an S3 bucket in my AWS account. And then I see we are creating an IAM rule, so that's great too. Let's just keep the encryption for now, keeping things simpler for demo purposes. And then the third step is the external volume creation. It looks fairly straightforward. So let's dive into the AWS side of the world. Let me log into my AWS console here. All right, so I have my AWS console I'm logged into. First, let's go to S3. Let's create a new bucket for this lab. It's going to be in the USS2 region, general purpose, just leaving the default settings as is. Let's just call it Iceberg Cortex Lab. Then just leave all the default settings as is. I don't want to mess with anything because a simple one works for me. All right, so I have Iceberg Cortex Lab. This is great. We don't have anything yet, of course. All right, so we have the bucket created. So the first step is to go ahead and create an IAM policy. Go to the services. Do I have IAM? So I have policies here. Let's just create a policy. I'm just going to use the JSON version because it's easier that way. And also, before we create a policy, if you want to just make sure the account settings is set all right for you. Say, for example, we can go to this security token service, and the endpoints, we want to make sure if the Snowflake region is enabled. Now, coming to the policy creation itself, I'm just going to use the JSON from the docs page and then just, fill in the details for the name of the bucket that we have. So I'm just going to use that. My bucket is, Iceberg Cortex Lab. That's the name of the bucket. I guess we are good. If you want to call this policy something, let's just, keep it in sync with the docs so we're not missing too much. So I'm just calling it Snowflake Access. Cool. All right, so we created this IAM policy, and the next is to create an IAM role. So let's go to the S3 console again, roles, create a role, use AWS account. This account require external ID. Let's select what should be the name of the external ID. Let's just get it from here. Just call it the Iceberg table external ID. Then find the Snowflake access policy we just created. Then give it a name. What do we want to call it? It's a specific name we want to give. I'm just going to call it Snowflake access role. Maybe lab, just so I don't forget it. And then this looks great. So let's just go ahead and create a new role, right? And once we do that, what's the next step? Let's not, I am, for this example, not going to do anything with encryption, like the Cadence encryption keys whatsoever. Skip that. I am moving on to creating an external volume in Snowflake. So switching back to the Snow site, or like the Snowflake UI, let us fill in the details here to create this external volume ourselves. I'm just gonna call, what's the name of the storage location? US West 2 S3 location. It's Iceberg. All right, so to create the external volume, we just updated the name of the storage location. Storage provider is S3, and the name of the S3 bucket that we had created. And then the storage role ARN. So we just created this role, just copy the ARN from here, use that here as well. And then the storage external ID. And I'm not using Azure, so I just deleted anything else that I have. And then once you run it, we will be able to see that the external volume is created. And then once that is done, let's just quickly describe the external volume. We will get the details, and I want us to get into the property value of this one and specifically look for the storage AWS IAM user ARN, and the value for that is here. And we want to copy this from this output. What is that? The storage AWS IAM user ARN, which is this. And then once you copy that, we go back to the role that we created, AWS role, go to the trust relationship, edit the policy, and update it to the ARN that we just copied. From here, right? The storage AWS IAM user ARN. Very much just following the documentation here. Nothing complicated, just update the Snowflake user ARN in there. That's it. And once we do update that, we are good to go and create an Iceberg table. So you can do that as well. Just, in the Iceberg table example, we just need to update the external volume, which is the external volume in here. And then just the demo and the product reviews is the prefix where we will have these Iceberg table, store the metadata and everything else. And we're using Snowflake as the catalog integration because we're not working with any external catalogs. Just run through this and you will be able to create an Iceberg table. So this is great. So far, what have we done to quickly review this, documentation is that we created an IAM policy and an IAM role, followed by creating an external volume and update the trust relationships with the Snowflake ARN, and also created an Iceberg table. Now let's go to databases and see if we have this demo public tables product reviews table. You see these are columns that we created. Currently it has no data because we've not loaded any data into it. So let's get to actually loading some data into there, right? So I have the product reviews dataset available in the open S3 bucket. So we just have to read it into these Iceberg table that we just created using Snowpark. So let's just run that. What is going on? Maybe the session was inactive. Yep. All right, so we were able to create the file format and also create an external stage to read the data from that S3 bucket. Whoops, typo. And here, if you could see, we're just, explicitly defining the schema so we could read that file from the stage into this Iceberg table. So this is how the data set looks like. We just read the January's data into this data frame, and it has all these columns that we just talked about. Currently the sentiment is null because we've not run any sentiment analysis on this data. Now let's write this data into the product reviews data set from this data frame into the table in an append mode. And if the write is successful, I should be able to see the data here, all the January's data. Fantastic. Now, another interesting thing is that we may be actually able to see all these files, right? Because we wrote it into Iceberg table. The actual data is going to be in your S3 bucket. So when you go to S3, oops, I don't even want IAM. I want to go to S3. The bucket name is Iceberg Cortex VHOL. Demo, product reviews, data, and metadata as well. As you can see, it's an Iceberg table, right? So you're going to have the metadata JSON and a bunch of Avro files like for the manifest and everything. And the actual data itself is stored under the data prefix in the form of a Parquet file. So everything looks great. Continuing with now, first, we were able to load the data from an S3 bucket. Second, we created an Iceberg table from that data. Now, let's go ahead and run these Cortex LLM functions for sentiment analysis, right? So let's just, what are we doing here? If you see, is that we just run the sentiment function to get the review sentiment, like the product review sentiment. And as you can see, this is how the product review sentiment looks like. And let's now update this Iceberg table with this extra column that we have, correct? So how are we going to have to do that? I'm just going to use another very interesting thing is that I could refer to the output of one notebook cell in another. So I have, maybe I will just call this Jan, just so it's all uniform. And because I'm referring to that here, it only has January product review. Hello, hello. So I have the January data in there. All right, so this is successful. So if we go back to check the product reviews dataset, it need to have these sentiments updated. So I'm going to the product reviews dataset. If I do a quick refresh, I should be able to see the sentiments updated as well. Fantastic, right? Now let's actually go one step further. The product reviews that we had only had the product reviews for January. What if we had this incremental data that's coming in for product reviews, perhaps for February, right? We will create the stream, like a Snowflake stream, to actually refresh this data set into this Iceberg table. And how are we going to do that? Like with the combination of streams and task. And as you can see, we just defined a stream for like the product reviews data set, like on the table product reviews data set. And we are going to create a task to update this with any new data that's coming in. So let's just run this quickly. Now we're loading the February's data from the external stage as well. In this above example, we defined a specific schedule, right? We wanted to run it on a schedule, but now for the purpose of this demo, let's like manually trigger that task to run and don't wait for the schedule to actually trigger the task run, because we want to check the values of the February data now. So let's just do that. Awesome. So this is scheduled to run immediately. So the February data will get populated and added to the product reviews table. And once we have the Feb data as well, now it's time for us to like, play with both the data sets together. So let's just go ahead and see from the 62 rows in January if it is updated. Yeah, so it is updated to 100 rows. If we perhaps can look at the review date, we can see that the February data is also now in the table because we manually triggered the task to run to update it with the February data. So we have both Jan and Feb. What if we could maybe compare the change in sentiment from Jan to Feb, right? On month, how the product sentiments have been changing or how the products have been doing generally. So as you can see, when we group by the product name for every product, you can see what the sentiment looks like for each month and what the difference is. And maybe to visualize it in a better way, we could definitely plot it in the form of a chart as well, thanks to Streamlit in Snowflake again. As you can see, some of them have, changed for worse, the phone holder and the fitness band and more, but the others have changed for better with an increase in the product sentiment. Like the positive numbers being the positive sentiment, negative numbers being the negative sentiment, right? So this is how you could combine the data that is sitting externally in a cloud storage location, access it using Snowflake, analyze it, and then couple it with Cortex to derive insights from it, like meaningful insights from it, right? So this is the first part of the demo where we talked about, reading the data, use Snowpark for aggregation and analysis, and Cortex for sentiment analysis. Now let's go to the last part of the demo where we show how to actually read the Snowflake managed Iceberg tables from an external query engine like Spark, for example. So let's first go back to the quick start, see where we are, right? We were able to do this part. We loaded the data into a CSV. This was all done. We were able to run through the Cortex functions as well. So this is great too. We also were able to create a CEC pipeline, trigger the task immediately, update the data with the February, update the Iceberg table with the February's data, then run sentiment on that as well. It's all good. Now it's just the last step pending where we need to read these Snowflake Iceberg tables from Spark. So let's do that. So to install all the dependencies we need to run Spark, let's download this env file, like the YAML file, and create a new Conda environment to install all the dependencies, activate the Conda environment, and then open a Jupyter notebook to actually run through our Spark code, right? So first steps first, I'm just going to copy these contents of the YAML file into, say, my own directory. All right, so this is where it is. I have this environment YAML where we've copied everything. I just changed the name of this environment to be VHOL, but you could leave it as demo, not a problem. So that is good. And then the next is to create this new environment, Conda environment, from this YAML file we just created. It's gonna take a bit of time installing all the dependencies. All right, so we have everything installed. So let's just go ahead and run this Conda activate and then Jupyter notebook. Once we have the Jupyter notebook running, as we can see, we only have the environment YAML. We don't need this anymore. It's already installed, all the dependencies. Now, what should be the next step? Well, we need to download the .env file to update the environment variables, to connect Spark to Snowflake, to read the Iceberg table, and also to connect it to AWS S3, which is the cloud storage, to read the actual data and the metadata from the Iceberg as well. So to establish this connectivity, we will have to update the env file here. As you can see, need to update it with the Snowflake account identifier, username, password, and the URI as well. And then on the AWS front, we need to update it with the region, access key ID, secret key, and also the AWS session token. I'm not touching anything from the Azure front because I'm not using Azure, but if you do, please update the Azure side of the env file, right? So there is this one file. I'm just going to download the raw file, and also the Spark notebook. I'm just going to download this notebook in here. Let's just quickly review what the notebook looks like. Not too long. So now I will go to this, just update my env.txt, also upload my Spark. Now you need to rename your env text file into a .env file. So if you have the terminal, you could just go and rename it. So that way, if I see this in the terminal, I have the env text file, but then I also made a copy of it and saved it as a .env, the environment, variable file, and the Spark notebook, and everything is good. Now, first, we need to update the .env, right? We need to update the .env with all the Snowflake details and the AWS details. For the Snowflake details, where do we get the account identifier? Let me show you my env file. All right, so this is how my env file looks like. The account identifier would be, if you have to go find it in the Snowflake account, go to this on the free trial account, the account name, click on the account, and this is the account identifier. And when you say, if I have to just paste the account identifier, how would that look like? So the account identifier here has a period in between, but you should be using a hyphen. That's what makes an account identifier. So fill in the right account identifier to the account details, otherwise you will have connection problems like later, right? And everything else is straightforward. The username and password. And where will you find this catalog URI? Again, go to Snowflake account. The URL, like copy the account URL. What does the account URL look like? I'm going to show you again. So this is the account URL that looks. So you don't need the HTTPS. Just take this portion of it and then, let it, just append it after the forward slashes. So that should be your account URL. right? So all the Snowflake details are completed. And coming to the AWS, very straightforward: access key, secret key, and the session token. And all of my session tokens are expired, so I'd have to get the new session token and update it here along with the password. So I'm just going to take it away for a bit. All right, I updated everything to the env file. And once we have the env file updated, all we need to do is just open the Spark notebook and just like run. We could just simply run through the import statements. Nothing happening here. All right, so I updated my env file with the latest access key and the secret key for the AWS, just like restarting, so we could just reload the .env file again. All right, this is great. It's just a bunch of warnings again. Well. So we were finally able to read only if you give the right access and the secret keys to talk to AWS, and also the right account identifier and the account URL to talk to Snowflake. We are able to read the Iceberg tables that are in Snowflake from a Spark query engine. So we're using PySpark to read that. So let's do a bit of, aggregation or like transformation that we did. First, let's try to count distinct number of reviews per date, I guess. So for every day, we are able to see how many reviews have come through. And then we're also trying to, again, a bit of experimentation to just show you that we are able to read and process the data that is sitting in an Iceberg table in Snowflake, right? So for every product, we're trying to calculate the average sentiment here in this query. And then now I'm just reading this entire product reviews table into a temporary view, just so I could filter it by the different, months here. So I have the Jan DF to filter the January query, like the data for all of January, and then the average sentiment per product for the entirety of January, right? And now let's do the same thing for February, and then really just compare how the change in sentiment happened from Jan to Feb as we moved from month on month, right? This is very similar to what we did from Snowpark as well. This is very interesting. I don't think these numbers are any helpful. So let me just go to this. Try to round this off, maybe for 4 digits, just so we can compare it. Yes, so if we see these numbers in the sentiment diff, and then maybe go back to Snowflake Notebook and see these numbers from the sentiment diff, I do see that it's actually the same numbers, which means, honestly, you could be using Snowpark to do the same transformation within Snowflake, or if you want to read it externally from a query engine like Spark, you could do the same thing. You can read data from an Iceberg table in Snowflake using Spark as well, just as you see here. So with that said, we are at the end of the lab. So you can also do a bit of a cleanup. So let's do that before we really wrap this entire thing up. So let's drop the database, warehouse, and the external volume, and then also create the deactivate and remove the Kona environment that we created as well. So please do run the cleanup steps, just so you're not running these on a continuous basis, because we did set up the streams and tasks to incrementally refresh the data, right? Especially if you are running this lab on your own Snowflake account, please do remember to clean up. All right, with that, we are at the end of the lab today. I hope this was useful for you, and go refer to the quick start and keep building. Thanks, everyone.